Ruler. What happened?
Okay. Hi guys, my name's Christina Hager. I just got married, so I'm kind of in that transition time period. But I'm here to talk to you today about a little bit about myself, and I've kind of detailed the different jobs that I've had over my career, and a little bit about why I picked the college I picked. I want you guys to ask questions as you have them. So if you've got a question that comes up while I'm talking about something, please feel free to just stop me and ask me. So this is really, I kind of geared this towards, you can learn a little bit about me and then maybe learn a little bit about yourselves at the end of it. So a little bit about my robotics career. I started in 2000 at Richmond Community High School, which used to be over off Libby. And I started there just generally taking pictures for the team. Somebody asked me to come out and be the photographer during the build season and during the competition. And I thought, okay, I'll come out and take some pictures. I didn't have that much of an interest at the time in engineering or robotics. Well, after I came out to the build season, the competition, I was hooked on it. I thought I want to get into this a little closer to my home. I grew up in Chesterfield County. So I joined Chesterfield Tech, which is now L.C. Byrd High School, Team 346. And on their team, I was mainly a builder. I did some of the driving and some of the strategy. And then my senior year of high school decided that wanted to get more involved and closer to my school. I went to James River. So a couple of friends and myself, we started one at James River High School, a FRC team. Back then there was no FTC or FLL or anything. So we started FRC team at James River High School. And from there I mentored at Benedictine High School, and they're paired up with St. Gertrude's, they're the Holy Rollers. And currently I'm with Midlothian High School. The James River team didn't have enough support, so they ended up joining with the Midlothian High School team. So that's a little bit about my robotics experience. It's been about 15 years that I've been involved with robotics in one form or another. So a little bit about myself. I went to James River High School. I graduated in 2002 from there. And when I was looking at colleges, I was very involved with robotics, and they kept telling me scholarships. There's all this scholarship money, and that you'll go to the competitions, you'll hear. People will tell you there's all this money available. It's true. They actually give scholarship money away. So I applied to schools that had FIRST robotics scholarships, and those at the time were Florida Tech for their aerospace program. It was Alabama, and they also had one at VCU, Virginia Commonwealth University. So I decided to go to, and I'm sorry, not Alabama, it was Arkansas. I decided to go to Virginia Commonwealth University because of the program. I went to visit the school. I was somewhat familiar with it growing up in Richmond, but I talked with some students that were currently in the program. It sounded like it was a much smaller school. You got more personal attention. You could lead committees and things like that if you wanted to, and that was what my interest was, where I wanted to go in and be a leader. I was coming from being the project leader on our robotics team and a leader in the math department at my high school, and wanted somewhere that I could have a lead role. Other schools that were really interested in me was Florida Tech. Their program just sounded amazing, but their scholarship wasn't a full scholarship, so it was hard for me to justify turning down a full scholarship too. While I was at VCU, I majored in mechanical engineering and then minored in general business, mathematics, and physics. And I'll kind of talk with you later about choices.
How many years did it take for you to go through all that?
4 years.
Before you did all that in 4 years?
Well, yes, the school was paying for 4 years of college, as many classes as I wanted to take. So I thought I'm going to take as many as I can possibly do. And another thing, some of these, like the mathematics and physics, I only had to take 2 additional classes beyond my core classes to be able to get those minors. And you look at that, you're like, okay, maybe you have an engineering degree, but I've noticed that people really find that business degree with an engineering degree, even though it is a minor. Companies really like that when they're looking to hire. They like somebody who's got both the business and the engineering background. So while I was, after my freshman year, I interned at Philip Morris International, which is Altria. It was down on right off of 95. Interned there and then was going to school at night. So that's how you do it. You go to school during the summer at night. And after that, and I'm going to go into detail about what kind of these jobs were related around and what I learned from them. So you can kind of see what I got out of it and maybe learn now what it took me years to learn. So next I got an internship at Dominion. And one thing I wanted to say about this is I got the internship through another scholarship called a Dominion Diversity Scholarship. So with that scholarship comes a paid internship. So look at companies in your area like that, because a company or a college that's going to give you money to go there wants you to go there, and they want you to succeed, and they help you succeed. So so I started off with Dominion and I put Chesterfield Power Station here. I'm sorry, I interned at Chesapeake Energy Center out in near Virginia Beach area. And then from there, I became an engineer one for Dominion at one of our power stations, and have had kind of a various roles throughout, and I'll go into more detail. But while I was at Dominion, and this is important when you're looking at a company, I know you guys have a while before you're doing that, but while I was there, they offered us free tuition if we were continuing a degree. So I decided to continue my degree in general business for business management. They support you doing engineering. I know people who got nuclear masters, and lots of opportunity there where you don't actually have to pay to go to school and you can continue learning. And as you will find out soon enough, it is very expensive to go to college. And then last year, I started, along with some others, a non-for-profit that's called I for STEM. And it was basically initially started because people at James River were saying, we have this money and people are donating it to us, but it's got to go to the school first, and then the school will give us the money, and that turnaround time was a long time. So we started it for that purpose, and now we've looked at opportunities as far as holding robotics workshops and things like that. So that's still in its infancy, but trying to get that to grow. And so I don't know, you guys probably haven't seen Office Space, but the older ones probably had. So I'm going to tell you a little bit about my jobs, specifically my roles in them and what I learned. So at Philip Morris, my job was an engineering intern in their cigarette manufacturing projects and technologies group. It's a big thing for basically saying we do new stuff that doesn't happen in the United States. I was in the international, so this was products going over to Japan. So one thing I got to do is I actually got to design a new package that was going over to the Japanese market. I got to lay picture on it, look at opacity of it. A lot of opportunity as far as me getting out there, get my hands on things. They actually identified a problem that they consistently had, and I was able to design a new way of cutting a box so that they actually wouldn't have those problems anymore, and it saved them a lot of money, and got the respect kind of some older people at that company at the time. So looking at new design, new packaging, new equipment, and the things I learned from that were that was when I was in college. It was more technical, machine drawing, mechanical drawing, and how to read it, and also how to edit it so that if I wanted to edit it for someone else to make changes for me, that they would be able to understand it. They put you in welding workshops, MIG and TIG welding, very cool. And then I also learned that voicing my ideas and opinions was a good thing. Sometimes you think, I'm an intern, I don't know if I know as much as this guy does, but a lot of times you guys offer ways of thinking of things, and you'll see this on your robotics team, a way of thinking of something that maybe nobody else thought of. And it's usually not a stupid idea, because even if it's not the idea that you use, ideas can grow from it. So I thought, voicing my ideas and opinions to others was really helpful in that job. And then also you learn the way corporate world works. So My next internship was at Chesapeake Energy Center. This was through the scholarship, so they let me pick where I wanted to be, and I knew I wanted to be at a plant. So that's one thing you guys are going to need to decide. Where are you going to want to be? Are you going to want to be in research? Are you going to want to be in a corporate office? Or are you going to want to be out in the field? So it's something to kind of think about and start figuring out what you like. There I did testing of new coal sources. Right now at that time at the plant they were only taking coal from the North America, and then they started looking at South America, so we were testing new product. Inspection of any equipment. I know Frank Brayton came to talk with you guys at the beginning of the year. I think he kind of went into detail about how a power plant runs and what type of products there are. So at a coal-fired plant, you have to crush the coal, pulverize the coal. So I often would have to go inside these pulverizers that are about the size of me, and you crawl inside, and I was the smallest person there, so I got that job to do inspection, which actually turned out really good because I learned a lot from it. And created some user interface screens that the operators actually still use today at the plant. And the thing I learned about that is when you take a project, you have to see it from start to finish. You know, you have to take ownership of that project, whether things happen good or bad with it. You know, nothing is going to go as planned, but you need to know why you made a decision. And also learn more of the technical side of it. And how things were different in the plant versus before I was at a corporate office. And I kind of figured out what I liked about each one of them. So then I decided to take a full-time job with Dominion at the Chesterfield Power Station, which is located by Dutch Gap. It's right off of 95 off of Route 10 in that area. And my job there was a Unit 3 engineer. So at the plant we have 8 units. And I was the Unit 3 engineer and Unit Common, meaning I was the coal yard engineer. I basically got that job because nobody wanted it, and you'll see that's really the story of my career, is that I've been taking on things that nobody wants, and it turns out to be something really good. So when I was working in the coal yard, we kept having leaks in one of our tunnels, so I worked on installing a sump pump down there so that it could pump out the water and we wouldn't have the leaks anymore, wouldn't have wet product. Also did a variety of things like turbine overhauls. I think somebody had asked, I watched Frank's CHED talk, and somebody asked how tall a turbine is. Is that person here? I don't know. Does anybody remember that question? And
Was Frank here last year?
it was February, I think, of this year.
Okay.
So he asked how tall a turbine is. So I put a picture on here. I thought I would just tell it because he said, I'm not really sure. But there is no one answer. I think that's why he wasn't really sure. There's all different levels of turbine blades. Anything from as big as a windmill to as small as my pinky. You could have a turbine blade that small. So at Power Station, they've got high pressure, intermediate pressure, and low pressure turbines. And those work off of steam that goes through the turbine. So high pressure is going to be very angled and very small, size of your hand. And low pressure, there's not as much pressure in the steam, so you're going to have much bigger turbine blades. So I've actually seen them like the size of me. I had one that broke, somebody gave me from a turbine that had wear issues, and it was literally the size of my leg. I could barely pick it up, it was so heavy, the turbine blade. So just in case anybody was wondering that is. So what I learned is that you're not always going to know the right decision, because when we did this turbine overhaul, they basically opened it up and the rotor had sagged. The rotor is what's in the center of the turbine that spins, and it had sagged. So what was the best option to do at the time? We decided to take it and to an off-site facility that Westinghouse had, and do some refurbishing and sending it back. Well, I just found out this past year we had to do more work to it. So it may not have been the right decision, but it was the best decision with the information we had at the time. So just kind of remember that, is make sure you document what you're doing. And just like on the team, you've got your journal. You guys have a journal, right, that you track what you do every day. And you know, you may look back at, or you're supposed to have a journal, maybe I should say,
We have
and
several
then,
journals, actually.
okay, good. You'll look back probably at the end and say, why were we even thinking about doing that idea? But with the information that you had at that time, it was probably the best thing to do. So really take ownership of a project, even on your team here. If you see, it's not a blame game. It's not, oh, well, he told me to do it that way. She said to do it this way. If you're working on something, it's your responsibility to make sure that it goes right. So if you need to get your team members more involved, remember, get them involved. But any project you work on, it's your ownership. And then that job really helped strengthen my engineering knowledge, which helped me in my next role, where I actually worked on a trading floor. And I was trying to take a picture and get it sent, but I was having issues, so I copied this picture here in the middle, which is a trading floor and where they do dispatching of a unit. And my job there was, I was solely to give technical support to power traders. So we had 5 different plants, I believe, that I would call and talk with the plants every morning about what their issues were. And then I would be able to talk with the power traders, basically relate that into how many megawatts that they could bid into the market or how much natural gas they needed to purchase. I got to use some of my engineering there when we installed RTU, basically so that we could talk with the ISOs, and that's the person who runs the grid. So once the power is generated, it goes onto the grid and the ISO runs it. So I still got to use some engineering, but I was transitioning in this role more to business.
How did you jump from a plant engineer to someone pushing numbers?
So this was a position that was posted. I toured around the company to see what other jobs were out there, and I actually visited this site when I was an intern and just thought, wow, I want to work there before I die. Seems like the coolest job ever. And that position came up, and it actually said that they were preferring someone with an engineering background. They said business accepted, but prefer engineer. And I thought, well, wow, that job sounds really neat. I was not, in my mind, qualified necessarily because I was not familiar with these ISOs. I had not dispatched power or units before, so it was a leap for me. But when I went to the interview, basically in a lot of interviews they want to make sure you can problem solve. And what is engineering at first robotics but nothing but problem solving? So it gave me a good way to talk about what I had been working on. And that's kind of how I made the jump. It was something that I thought would be interesting. It was a little outside of my comfort zone, I would definitely say that. And I was actually working with plants that were outside of Virginia. All my work before with Dominion was right here in Virginia. So I was going to an unknown area for me that our company didn't value as, its main generation, as its main core value. So it was difficult in the fact that it's something different, but exciting in the fact that it was something different and something I was interested in. So the things I learned there really were organization, trying to help. I think mine's off right now, but it's probably gone off 5 times already. So I've learned organization from having that job, because I had so many plants that I had to manage and update people that really helped, figure out that I need to keep my spreadsheets updated. I need to stay organized. I also learned how important it is, the power price that we're bidding into the market. So right now, I don't know how much you guys know about power, but at the time I thought, okay, I'm just going to, there's a certain price, you pay so much for the fuel source, and then you multiply that by, the megawatt. So what's my price going to be that I'm putting in? There's a lot more that goes into it. Weather is a big factor that goes into power pricing. You've got congestion. So what's the need? What's the local need of the product? Are the transmission lines congested? Meaning, do they have any outages, or is there need on the lines? So that, along with the fuel source, goes into what the power price is. So I also learned in that one that rules are a lot different in Virginia than they are in New York. So I've worked for, I think at Philip Morris, we were definitely a think globally company, because I was working in an international group, but you can't just focus on what's going on here with you all in Virginia or in your school. You know, you have to look at what's going on elsewhere. So that's helped me in my job now. Let's see. I also learned the working environment. If you see the picture of the guy, I work on a training floor that's a lot like that, where it's an open floor. We don't have cubes. You know, you can hear what everybody's saying. You don't have any privacy, but you also can get answers very quickly. And I found that I really liked that working environment over being at a plant where I was at my desk, or out in the plant all day, or being in the corporate office where you're at your cube. So you kind of figure out what you guys are interested in. And one thing I wanted to talk about was renewable energy credits. When I was watching Frank's talk, it was more about how power generation happens. So I want to talk about a little bit about dispatching and where we have some value in these renewables. I don't know what you guys know about wind and solar and biomass, but it's normally more expensive than your traditional power sources. But the way that cost is offset is through renewable energy credits. So whenever we generate a megawatt on biomass, wind, or solar, we get a REC that we can sell. So that makes it more likely to dispatch those units. So a little bit about RECs. These are a REC renewable energy credit. This is a renewable portfolio that basically shows you, I really just wanted to highlight on the states that participate in renewable energy credits, buying and selling. Now, Virginia is actually a voluntary state. We are not mandated to participate in this renewable energy credit, basically buying and selling of it. We participate in it because we can sell those RECs and we can make money. So we can make money off it because there are areas where it's non-voluntary. So in New Jersey and Maryland, they have to have these RECs. In North Carolina, there's certain RECs they have to have. So that's why we participate, because other states need these RECs and we can capture money off of it. So one thing I want to talk with you is wind. When I was in that role, we started 2 new wind farms, one in Indiana and one in West Virginia. And if you see here, the renewable energy credits for the one in Indiana was 550,000 renewable energy credits in a year. Now I can put a dollar value. They're about $17, $18 for each one, and we had 550,000. So that money is money additional that we're making. So after that, an opportunity in my company came up, and I was approached about taking a job in the financial area of our company. It was something that way outside of my comfort level. I was an engineering kind of person, and that's where I thought that I would kind of stay in that field. Well, I did take the job as a financial analyst, and I looked at balance sheets, income statements. The job was really neat, though, because I actually got to look at all the power stations that I had been working with in my previous role and look at the dollars. So are they making money? Are they losing money? On a long-term basis, are they making money? Are they losing money? And I actually got to help management make decisions on whether to keep these plants open or close them down. So it was neat to see the company from that role. I also got experience with a biomass. We converted 3 of our coal stations to burn biomass. They just opened the end of last year, and I got to look at that project and evaluate what was the best, who was the best procurer to purchase the wood product for us. Dominion was very new to biomass, so we didn't want to just go out and be the ones who were purchasing the product ourselves. We hired someone. So I got to do that analysis. I also got to listen to peer and competitor earnings calls. So I got to hear what other companies valued as well as what our company values, and helped compile data for that so that our CEO, when he's on the call, knows more information, basically has reference information in case he gets asked questions. So that one, I learned really why companies make decisions. You know, when you're in the power, when you're making power, you're focused on that. My job is to make power and to get it out on the grid. But in this job, really learn, okay, why is our company shutting down this coal plant in Massachusetts, or why are we shutting one down in Eastern Virginia? And a lot of it is because the economics are not there. The finances say that if you run it, you're going to lose money. And with natural gas coming, which is so cheap, it's not always economical. And I also figured out what I liked and what I wanted. I worked a lot with spreadsheets. So Visual Basic Excel was my friend. But I didn't really want them to be my friends. So I figured that I like working with spreadsheets. They help me stay organized, but I didn't want to be in them all day long. So I looked for a job and found this job as a fuel planner. When I had worked at the station and in the coal yard as an engineer there, I had talked with people who purchased the coal for us. And when I was in my energy trading role, I also talked with the people who purchased the fuel for us. So I came in as a fuel planner for our merchant plants, which are outside of Virginia, and then one of our the newest coal plant that we just opened up, Virginia City, that opened in 2012. That's in Wise County, very close to Grundy. So if you guys know Grundy, I think they're 977. I don't know exactly their team number, but I remember when we first played them when I was in high school, I thought, where the heck is Grundy, Virginia? But now I know because I was driving out there all the time. My job there was more of a strategic role, which all kind of tied back to my robotics experience. On the team, on my robotics team, I was a strategist. So my role was building as well as strategy. So what was the robot going to look like before we built? And then after, when it didn't look anything like what we wanted it to originally look like, it was how are we going to compete with it now that we're here and we have this bag of bones, how are we going to compete with it? And that's what I found really interesting on that team. And when I was putting this presentation together, I actually realized, oh, that's exactly why I'm here in this role right now, because I do pretty much strategy all day, coordinating, scheduling. In this role, I was doing coal, and I was doing it for rail, for barge, and for trucks. And I realized that I really do love logistics. I'm very comfortable talking with people, talking with many suppliers. When I was in this role, I think we were sending about 200 trucks a day into our Virginia City plant, and I've got a picture of it. There you go. That's the one that was commissioned in Southwest Virginia. We actually made it on Power Magazine for one of the top coal plants in the country. But when I was working in that role, a lot of talking with people and negotiating with people, saying they're telling you, I want to send 200 trucks, and you're telling them I can only take 100, and how to make them happy so that they don't go somewhere else. So a lot of that kind of, so really starting to move away from my engineering, but still understanding the plant side. Whenever you're talking with somebody, you want to negotiate with them, they may be your customer, or you may be trying to get something out at the end of it, but you need to understand their point of view. So it's best to understand where people are coming from so you have good talking points. I think that works in any sort of negotiation. When you're all talking about the design of the robot, it's good to understand, okay, I understand your point of view. We can only get 20 points if we do it that way. We could get 80 points if you do it this way, kind of thing. So I put in here some slides to go a little more technical for you guys to show you the equipment that's required when you're actually mining coal. And this is what's considered high wall mining. So you take kind of the face of it off where the trees are, and they have engineers that go in, they drill samples to find out where the coal is, and then they'll actually map it on a program that the operator of this, and this is a $2 million piece of equipment that you're looking at here on top. That operator actually goes in and can follow the lines, and he just follows along where the engineer has plotted that he needs to be mining. And how it works is this on y'all's right. That miner head there will break into the side of the mountain, where the coal seam is, and it's kind of hard to see it, but there actually is probably a 2-foot high coal seam right there. And then the picture on the left over here shows that it's into, it usually can go anywhere from 600 feet they'll mine to 1,000 feet. They'll go into the wall and then pull that product out. It actually has a conveyor on it, and they'll spit out. So there is a lot of mechanical components that go into high wall mining. Yeah.
Why did you stay with Dominion for so long?
I stayed with Dominion because they treated me really well. They gave me opportunity to change roles. You know, I picked them over Philip Morris to start my career with because I saw more growth at Dominion. When I talked with the HR people there, the hiring people, a lot of people at Dominion are in their 50s and 60s, and that means that in 5 or 10 years they're going to be retiring, and there's going to be management opportunities. And I've been there 10 years now, and I'm already in a management position. And I saw room for growth. I liked what the company stands for. They really have a diverse portfolio as far as fuel sources. Their coal, their natural gas, their nuclear. I just went to a talk this morning actually about natural gas. They're talking about putting a pipeline in through Virginia and North Carolina. And they really care about customers. You know, the reason that they're doing it is because for fuel security of the product, but they also care about the people whose pipeline it's going to be in their area, and they're really trying to work around. And it just seems like they have the community's best interest. When I was working there, I got to volunteer a lot. They're very supportive of FIRST Robotics. They were actually one of the sponsors of our FIRST Robotics team when I was in high school and gave money to it. So it was a company that I could stand behind and stand up with their values. So one other thing, the coal here, I went out to this site and took some pictures of it, but we also take coal from basically refuge sites. So this coal is like a 10,000, 12,000 BTU product that you're looking at here, and that's the heat content, the BTUs are the heat content of it. This refuse waste coal is like a 5,000 BTU product. So we actually, for this particular station, we blend high BTU and low BTU coal together. So we can use what originally was just thrown away as waste, we can reuse it now. And companies are going in, taking the waste coal, and this coal was literally put there 80 years ago. So they just kind of threw it into pits and didn't clean it up. Well, now the companies are going and cleaning it up and making the area beautiful, very aesthetically pleasing, grasses and everything. So I also wanted to show you guys these pictures so you can see all the mechanical components here that actually takes to unload the coal by truck at our Virginia City plant. So you have what's in the top corner over here, you've got an auger sampler. That will actually go down and pull out a sample of the coal from the back of a truck, and we send that off to be sampled. We look at BTU, moisture, ash, and sulfur. All those are very important to your boiler stability. Then once it's been sampled, it's going to go dump. And from this picture, you can see that we've got a telescoping bed, meaning the bed of the truck actually lifts up in the air and the product comes out of the back. So I've also seen a bottom dump where it opens up from the bottom. There's new technologies coming out with trucks like this. The bottom dump ones, they can fit a lot more product in them. So, you know, the more tons you can ship, the more money that people can get, and they're likely to come to you. Once it's dumped into these hoppers, it actually goes out to a pile on a conveyor reclaimer, where it will dump onto the pile. And then, conveyor stacker, where it dumps onto the pile. And then this last picture down here is a reclaimer that uses paddles to grab it and bring it to the unit. Now, this is different than any other coal plant I've ever seen. There are a couple coal plants like this. The one in Chesterfield and Chesapeake that I worked at, you had large dozers that they just pushed onto a conveyor belt, and it got the coal to the unit. This way, you have a lot more mechanical components to it. So Shaw is the company that did all the building for us. So they're also somebody who hires a lot of engineers. They're building the new Vogel 3 and 4 plant down in Augusta, Georgia, which is supposed to be once it's built, it'll be the first new nuke plant in 25 years or so in the country.
Two more boilers to
I'm sorry?
add 2 more boilers to the Savannah area?
I'm sorry, I can't hear.
They're adding 2 new nuclear boilers in the Savannah
In
area. Augusta.
Well, Augusta, yeah. So right outside, and it's actually about 50 minutes outside of Augusta, but that's the nearest large city. My brother's actually, he went to school for nuclear engineering at Texas A&M, and he's actually working on the build of those. So I got to tour them, and it's fascinating that we have nuclear power now coming back, and other companies are using that same design to build new nuclear plants. But they're about a year or two at least behind where Southern Company is, who's building those ones in Georgia.
Do you know the efficiency of the nuclear boiler?
I don't. I would think that they would. I would think their capacity would be, in the 90s. But I don't know the exact number for the efficiency. But I can ask and I can email it to your teacher. So now in my current role, I'm a senior fuel supply coordinator for Dominion. Basically, I'm working only with biomass and with emission reduction products. So when coal is burned or biomass, when you have a product that's burned, usually you use limestone to reduce the amount of sulfur that comes out. So I've also, as well as biomass, looking at the emission reduction products, which is mainly limestone, urea, and ammonia. But my main is biomass. So right now I'm managing people who schedule over 2,000 trucks a day. So that's why when I said my phone probably rang 5 times, I'm always on the phone talking with people and trying to put out fires. I'm in constant contact with our biomass stations. We have 5 biomass stations. 3 of them were conversions from coal. One of them was initially a biomass station, and the other one is the Virginia City plant that I told you about. It is a dual fuel plant, so it burns biomass and coal there. So what I've learned from this job is that biomass is a lot different than coal, and I hear that a lot from my customer, that biomass is a lot different. But it really is. When you look at coal, and I was talking about the engineers and how they find the coal seams, the coal in a coal seam is going to be pretty consistent throughout the seam. You may have slight differences, but you're going to have a pretty consistent product. With biomass, it's not consistent. You may be in an area of forest and you've got hardwood, softwood, you've got pine. So you're really looking at a not consistent product. And Dominion as a whole, our mindset when we're moving product like this, it's coal. So they're expecting consistency on a product that isn't so consistent. So I brought some samples here, and I just wanted to, I'll pass them around, but all of these, everything, I'll start there and pass those. But it's all considered biomass. Wood, grain, let me go. So municipal waste, so when you guys decide that you want to cut down trees in your yard and it goes to the landfill and they grind that up, that's biomass. Chips that are chipped in the wood or at a sawmill, that's biomass. Dust from sawmill operations, the sawdust, I would have never thought it had so much of a value, but they use it on farms, we burn it in our boilers. I'll start another set going around this way. You see the difference there. But the important thing with wood is trying to figure out what your station requires. So our boiler can burn anything. It can burn the dust. It can burn, grinds. It could actually even burn, products that's that big. Yeah, it could be. But the problem is to get it to the boiler, it was not designed for that. So we have a biomass boiler that's only designed right now to burn chips. So what I'm working on with our engineering team at Innsbruck, which is where Frank works, what I'm trying to work with them is to actually redesign some of the handling system. Because if you look at, can you hold that bag up right there? Look at that bag. It's very stringy wood. Where's the first set of wood? Is it back over there? Can you hold that bag up? It's very blocky wood. So the stringy wood actually gets plugged up in different pinch points where the block wood will flow through and not have a problem. So basically looking at the system, it's kind of like when you design a robot, you test it and realize, oh, this arm not going to work right there. Well, the problem was they didn't really do much testing on these units before they started them up. It was these were converted and started back in 2012, and they were trying to use the existing machinery. Well, existing machinery was for coal, which is more blocky. It doesn't have the strength, so it's been a learning experience. And just to show you, I really wanted to highlight on this picture up here. So the biomass at our plants is not unloaded usually by the way the bottom picture is with the telescoping bed like what you saw for coal. The biomass is actually unloaded by the driver gets out of the truck, pushes a button, and the truck raises into the air and it falls out the back. A lot of biomass trucks are not as sophisticated as the coal trucks. So a lot of mechanical component going in there.
Christina, we've got kids' carpools.
Oh, gotcha.
So I hate to cut you off.
Oh, no, it's okay. Let me just give you one little takeaway. Have a career, not a job. So when you ask me why I picked Dominion, because I saw a career there. And then figure out what fits you. Are you a niche person? Do you like the mechanical or the electrical component? Or do you like to know a lot about a lot of things? So just make sure you figure out who you are. And then I got to give you homework because Dean always gives homework. So go back and talk with your family and talk with family or friends, people you trust, some hopefully adults, that you can talk with about picking a major and career in college, because you want to pick something that really fits you. So ask someone who knows you. And I think
we have copies of her slides as well, so I'll send those out on Google Group if you want to see the ones that we made her slides for at the end. Thank you very much. We wanted to give you, I know you have other team affiliations, but we wanted to